Hello everyone, I'm Dr. Nitin Kumar Saxena and this is my first lecture for the second chapter on electric field. In this chapter, we will start with the concept of electrostatic potential energy. And to understand the concept of electrostatic potential energy, we will start the concept of gravitational force. All of you know that when we have any mass body, so it experiences a gravitational force. And like if I'm taking a simple example that I'm throwing a ball upside, so what will happen? Like initially it has the kinetic energy, and that kinetic energy will be converted into the potential energy when it will go up. In the same way, when it will come down again, what will happen? Initially, suppose I am saying initially the ball is at, this is a ball. So ball initially at point A, and now I am throwing it up. So it will reach to B, and after B it will again come to A. A means let I am saying A is a reference ground. Right. So you see, when we are talking about the point A and point B, these 2 points always are in the range of gravitational energy, because we know that everywhere like we have the, if it is a mass body, then it will experience a gravitational force, except we are not in vacuum, right? So it is experiencing some kind of gravitational force each and every time. And since it's moving from some place, let it be from A to B, so this body has some energy when it is at point A, and like the energy is conserved, but it's changing from one point to another point, or in one form to another form, from A to B and so on, right, from B to A again. The same analogy we can use for the understanding the electrostatic potential energy, right? So what is that? So what to understand this? To understand this, that we see that we have a plus q charge particle, a point source charge particle, right? So this is a point source charge particle, and like we know that every point charge particle creates an electric field in radial direction from this. So we have electric fields which will go till infinite from this point charge in radial direction. And now I am saying a charge particle, suppose plus q, is placed at some point A, right? It is placed at some point A. Now what will happen? When this charged particle, and suppose I am saying this is a positively charged particle, it will experience a repulsion force due to this capital plus Q, right? So if it is experiencing a repulsion force, and now I am saying that I want to move this point charged particle from point A to point B. Okay, so in moving from point A to B, since it is experiencing some electrostatic force at this point also, and I want to move this particle, this charged particle, from point A to point B, so we have to do some work on it. And because of this work only, it is possible to move this charged particle from point A to point B. Similar to the gravitational force or gravitational energy, when the point charge is placed at A, it experiences it has some potential energy, electrostatic potential energy, and now since it is at the point B, it also has some potential energy, right? So if I want to move this charge particle from point A to point B, what we have to do? We have to do some work on this charge particle to bring it from the point A to point B. And the work done to bringing this charge particle from point A to point B, why we are doing work? Because like this is placed in electrostatic, this electric field which is produced by this plus capital Q charge particle, and to move this small plus Q charge particle which is placed in this, we have to do some work. And since we are doing some work, so this this energy will be stored in charge particle in the form of potential energy, right? So how can we define the potential difference, potential energy difference? So the work done by any external system, that we will discuss later what will be the external system. So by any external medium, external system, the work done to bring this charge particle from this plus Q to this, from this plus A to point A to point B, the work done is defined as the potential energy difference, right? So how can we define potential energy difference? So potential energy difference. So we can define that the work done by any external medium to bring the plus Q charge from one point to another point in an electric field is defined as potential energy difference. Okay, so how can we define? We can define as the potential energy difference, we can define as the work done by any external medium. We have some external medium that will try to bring this plus Q charge particle from this point to this point in any electric field, okay? And this is defined as potential energy difference. So you see, this definition is okay, but for drawing this definition, we have taken some assumptions, rather than two assumptions. What are these assumptions? To understand this, suppose in starting, if I am saying that this is plus capital Q, this is plus small q, and I am saying this plus capital Q producing a force on this. At the same time, this plus Q will also produce a force on it, right? So when we are writing this definition, we are considering the force on this plus Q, not on this plus Q. So what we are assuming? The first assumption is that we are assuming, that this Q is the value of this plus capital Q is very high compared to this small plus Q. And in that case, we can assume that the repulsion force which can be taken at plus q due to this small plus q is negligible, and we are not considering it, right? So for this, the first assumption is that we are considering the value of this plus q is very high compared to this plus q, and hence this implies that force on, suppose this point is O, so the force on A due to A, right, is very very less compared to the force on A due to O. The first assumption is clear. Now the second assumption is, suppose when we are giving the force, external force, to this charged particle so that it can move from A to B. We are giving an external force. So what is the purpose of this external force? The external force is like to maintain the movement of this charged particle from A to B in such a way that it has no value of acceleration. Okay, otherwise what will happen? We are considering the movement electrostatic. We are studying the electrostatic. And if the charged particle, because of this force, it has some acceleration, because we know the formula force is mass into acceleration. So if we are giving the force to any mass particle, it will create some acceleration will act on it, and due to acceleration it will come in dynamic, it will be in movement. And for this study we are neglecting any kind of movement, and hence we can say that we are bringing this charged particle from point A to point B by keeping its acceleration always zero, or the movement is very slow, like, so that we can say it's coming in a step, and hence there is no movement, electrostatic, like no acceleration. And for this, what we are doing, suppose I am saying this electric field is like this, so we are giving external force in opposite to this electric field, so that what will happen, these two forces will remain always equal and opposite, and due to which the net force on this charged particle is zero, and hence there will be no acceleration. So charged particle q is moving from A to B very slowly. This implies acceleration is zero. Is it okay? So with these two assumptions, when we are taking these two assumptions, the definition of potential energy difference holds good. And now I am again repeating, the work done by any external medium, F external, to bring this charged particle from one point to another point in presence of any electric field is defined as electrostatic. Again I am adding one thing, electrostatic potential energy difference, right? This is fine. Now I just want to know what is the electrostatic potential energy. Here we are moving the point from A to B, and now I am saying, okay, like if this point charge is placed at point A only, then also, like, since it is placed in any electric field, so it has some kind of energy which is stored in charged particle, and that energy is called electrostatic potential energy. Okay, so what is this? Electrostatic potential energy. So I'm again repeating that the charge particle plus Q is kept a point A. Since A point is in the electric field which is produced by this plus capital Q, and this charge particle, if it is placed at point A, naturally it means it has some kind of energy which is stored in this charge particle, right? So this energy which is stored in this charge particle is known as electrostatic potential energy. And how can I define it? So to define it, let's suppose I am like considering that initially this charge particle was at infinity. Okay, so if the charge particle was at infinity, what does it mean? It means that there on infinity there is no electric field. And since we can consider that on infinity we have no value of electric field, so initially no electric field means no energy is stored in the charge particle when it was at infinity. Now from infinity we are trying to bring this charge particle up to the point A. So naturally, initially when it was at infinity and now it is coming from infinity to point A. So for bringing the charge particle from infinity to point A, we have to do some work. And this work which we have to do, like by following these two things are also valid now. So when we are doing the work to bring this charge particle from infinity to any point, the work done is known as electrostatic potential energy. Okay, so how can we define? We can define the work done by any external force, external medium or external force, to bring the plus Q charge from infinite to any point in any or in a electric field is defined as electrostatic potential energy. Right? So we are bringing a charge particle from infinite to any point, which the point is lying in the electric field. So the work done to bring it is defined as electrostatic potential energy. So I hope the concept of electrostatic potential energy and electrostatic energy difference is clear to you. Now see, this we have defined the value of energy. Now we want to know what is the value of electrostatic potential, and similarly what is the electrostatic potential. Okay, so like potential means when we are doing some work, so what strength we are giving to do that kind of work. And to know this, like if we assume that okay, in place of this plus Q charge particle, if we are bringing a unit charge particle, okay, so for the work done to bring a unit charge particle is called electrostatic potential difference. So if we want to know the value of electrostatic potential difference or electrostatic potential, so what we will do, we will divide these values by the charge particles. so that we can get the value of work done for a unit charge. So let's see, mathematically I can say, okay, and in first case, for this first case, W is suppose UA minus UB. So UA is the electrostatic potential energy of A at point A, and UB is electrostatic potential energy at point B, right? If I am saying this is at infinity, so I can write this UA. So this formula is for this, and this formula is for this, right? So what I am saying W is UA minus B. UB means the work done to bring this charged particle from point A to point B, and is called electrostatic potential energy difference. And when we are bringing it from infinity to point A, then we will say that this is electrostatic potential energy, right? Or mathematically, the another formula which we can say, yes, W is, the work done is force into displacement, also this another formula. So the force is F external, and if it is moving from A to B, so what we will say, it's moving from A to B, right? Is it okay? Similarly, since you know that this force of external force is just equal and opposite to this electric force. Why? Because we are giving this external force so that it will always keep the value of acceleration 0. So it must always be equal and opposite to the force which is experienced by this charged particle due to this plus capital Q, right? So we can say like this also, right? And in general, if I want to take any small segment, suppose this small segment is dx, right? So what will be the value of del W? Del W will be F external del x or minus F E del x, right? Now I want to know that this is the work done to bring the charged particle from this point to this point. Okay, now I want to know to bring from point A to point B. So W will be integration from x equals to A to B F external del x or minus from A to B F E, and this del x can be written as dx, so dx. This is fine. So mathematically we can write the expressions for electrostatic potential energy difference like this and this. And if the point is from infinite to point A, so what will be the change? The change will be like this, that yes, x equals to infinite to point A F external dx, or from x equals to infinite to A F E dx, right? So again I am quoting that these formulae are for this, and this is for this, right? So we have seen the potential energy, electrostatic potential energy and electrostatic potential difference. Now the second point is that what is the value of electrostatic potential and electrostatic potential difference. So as I previously I told you that if I want to know the potential, so what we can do, we can divide the potential energy that for bringing the plus q charge particle from the work done to bring the charge plus q charge particle from the point A to B is called potential energy. And what is the potential? So potential means that what we have to do work on it. So simply we will divide it by unit charge. So if I want to know the definition of if I want to know the definition of electrostatic potential energy, potential difference. So what I will say? The work done to bring a unit charge. The difference will be, in place of plus q, what we will do? We will write unit charge. Okay. So the work done by any external force to bring this unit charge from one point to another point in any electric field is defined as electrostatic potential difference. Okay, so when we are talking about energy, we will take plus q charge. When we are talking about the potential only, then we will take unit charge. In the same way, if I want to write the definition of electrostatic potential, so again what I will do, I'll try to bring a unit charge particle from infinite to the point A, and again the definition of electrostatic potential will be same as that of electrostatic potential energy. The difference will be here that it would be unit charge only. So what will be the definition of electrostatic potential? The same, like we will change only this plus q by unit charge. So what we will say? We will say the work done by any external force to bring the unit charge from infinite to any point in an electric field is defined as electrostatic potential. This is clear? So I'm briefing what I have told you by the definition. Mathematically I can write. How can I write? I can write the first thing, electrostatic potential energy difference. Second is electrostatic potential energy. Third is electrostatic potential difference. And last is electrostatic potential, right? So these are four things. So you see this is defined as UA minus UB. This is defined as UA. This is defined as UA minus UB divided by Q, and this is defined by UA by Q. So the difference is clear that if we are taking for any charge particle, then it is energy, and if we are taking it for unit charge, then it becomes potential. I hope the difference between the potential energy and potential is clear to you people, and if it is clear, then let's see the mathematical expression for electrostatic potential and electrostatic potential difference. So to understand this, suppose topic is potential, electrostatic potential due to a point charge. So electrostatic potential due to a point charge. Suppose I am saying here at point O, we have any source charge plus Q. Source charge means the electric field throughout the space is produced by this charge particle, and hence it is called a source charge, right? And now, like if I am saying, okay, I am saying any, like I want to place a charge particle plus Q, suppose, okay, or since we are talking about the potential, so we will say unit charge, and like we are like initially we are taking this is a unit charge. Otherwise what we will do, finally we will divide by the value of this charge particle which we are taking here. So from the initial point we are taking that a point unit charge is placed at point P. So what would be the potential, electrostatic potential value when this plus charge is placed at point P? So and we are assuming that yes, the distance between O and P is R, right? This is clear. So the question is clear. So what we will do, we have any, I am repeating again, we have any plus Q charge particle which is placed at point O, and now a unit charge particle plus 1 is placed at point P, and now I want to know what is the electrostatic potential, the value of electrostatic potential at point P, right? So to find this, suppose I am saying, okay, this plus 1 charge particle was at infinity, this was at infinity, and now I am bringing it slowly and slowly. Why slowly and slowly? So that acceleration will remain 0. Okay, so I am bringing it slowly from infinite to point P, and initially suppose at some point it is at this point, let this point is suppose A, okay, and this distance R dash from this point O, okay, and now next step it comes at B, and the distance between A and B is del R, right? So if I am saying if the charge particle is at A, what charge particle? The value of charge particle is what? Plus 1. So this is at point A. So naturally it will experience a force. What will be the value of force? The force on charge particle when it is at point A will be 1 upon 4 pi epsilon naught, okay, Q1 Q2, so Q1 Q2 upon this distance. What is this distance? R dash. Is it fine? R, or simple, like I'm like avoiding the confusion in terms of dash etc. So I'm taking this as x and this is del x. So what I'm taking this distance is x and this is del x. So if I'm taking so what can I do? I can say that this will be the distance from A to O will be x square. This is fine. Now force on this plus 1 charge particle when it is placed at A, since this point is at the distance of x from the point O, so the force is given by this formula. Okay. Now, against this, since the direction of force is like this, now what we are doing, we are trying to move this charge particle from point A to point B. What is the distance between point A and point B? Del x. And we have to move this charge particle from A to B against the electric field. So we have to do work. Okay. So if we will do some work, so to bring this charge particle from A to B, we have to do some work. And since we are doing some work, so what we will say, minus force into displacement. What is the value of force? 1 upon 4 pi epsilon naught q upon x square into del x. This is fine. So the work done to bring this plus 1 charge particle from point A to point B, the value of work done will be this. Is it fine? Now this is for the small segment AB. Now I want to make the work done for the whole process from infinity to the point P. So what I will do, I'll simply make W will be integration of del W or integration of dW. I can replace this delta by d. So minus 1 upon 4 pi epsilon naught q upon x square. Again I am replacing this del x by dx, right? So what is the value of x from infinite to x equals to t? So what is the distance of p from O? R. Is it okay? So minus 1 upon 4 pi epsilon naught, q can also be taken outside. So integration of 1 upon x square dx, where x is from infinite to r. When you will solve it, minus 1 upon x, you will get like this. Right? Now substitute the value, what you will get? 1 upon 4 pi epsilon naught. This minus will cancel out. Q upon R. Q upon R. And by the definition, you know the work done to bring a unit charge particle from infinite to the point, any point, is defined as electrostatic potential. So this will be the value of electrostatic potential at point. Either you can write like this, P, because this point is P. So this will be the value of electrostatic potential at point P. 1 upon 4 pi epsilon naught into R. I hope this mathematical expression is clear to you. And if you see the relation is that if we are increasing the distance R, so the value of electric potential will go down, right? Naturally, if the charge point is far away from the point of origin of electric field, the potential will become down and down and down. And if it is close to the origin of the electric field, then its value will become more. Oh, I hope the concept of electrostatic potential difference, the potential energy difference and potential, and the mathematical expression how can we find the magnitude of electrostatic potential at point P is clear to you. Next class we will discuss the other concepts related with electropotential, what would be the value of electric potential, due to electrical dipole, when there are number of charged particles are placed in a space, and other concepts also. So for this lecture, I hope it's clear to you, and let me allow to finish this lecture at this moment. Thank you very much.